This video is about solving a limit using simple. Okay, so this video is about solving a limit using simplification, right? So you want to simplify the equation before a limit, basically what I mean. So given the limit of x approaches -2 of x squared plus 6x plus 8 over x plus 2. Okay, so now we want to, before we do a direct substitution, we want to see, do I have a negative under the square root? Since the equation we're looking at doesn't have a square root, so you don't have to worry about the rational function, the square root, the square root, right? So, okay, so that's the first check. The second check, do I have a 0 on the denominator if I substitute x equal to -2? Yes, right? Because our denominator is x plus 2. And if you sub in x is equal to -2, then you got -2 plus 2, which is 0. So that's a problematic there. Is there a way that we can simplify in the equation before we taking the limit, right? So we're going to, okay, let's see if we can do anything from the numerator. Can we factor out the numerator? Yes, right? Because I have this equation here. So let's factor out the numerator. So my problem is going to be limit of x approaches -2. The numerator is going to be factored out into two different factors, right? I have x, and you need a number that multiplied to be 8 and added to be 6, which is, I can come up with 4 and 2, right? So if you multiply 4 and 2 together, you got 8, and you add 4 and 2, you got 6. Okay, so now, and the denominator, I'm going to keep it the same, but I'm going to put it in the parentheses so that you can easily see. So do you notice that the numerator and the denominator both have x plus 2? So from here, we can cancel out x plus 2, right? Because we have multiplying. So now from there, you have a limit of x approaching -2 of x plus 4. This doesn't give you any problem if you substitute in x is equal to -2, right? So if you sub x equal to -2, then your limit is going to be approximately -2 plus 4, which is 2. Right? The reason is not equal to because in these functions, the function does not exist at -2. At -2, you have a discontinuity there, right? You have a hole basically. Okay, so your functions will look, if you draw it out, your function might look something like, I'm gonna do approximately draw out, look something like, oops, like that, and at 2, and oops, I'm gonna pretend that is at 2, and at 2 there's a hole there, right? So that is why f of 2 here does not exist, because in the domain there's no doesn't exist at x equal to -2, sorry, -2, not 2. Okay, so this is the problem where you have to simplify your equations before you take the limit. So that's why simplification is really important in math. So I hope that helped.